Let's look at an example of a rational function in which we use transformations. Let's look at f of x is equal to a 1 over x minus 3 minus 1. Now, going back to our transformations, a couple of things we need to remember here. Remember things that were attached to our x's. Those things were our horizontal shifts, meaning we move things left and right. Okay. So we move things opposite of what we thought. So if it was positive, we moved it left. If it was negative, we moved it right. So in this particular case, since it is a negative 3, we are going to move our entire graph right 3 spaces. Which means our vertical asymptote will become x is equal to 3. Because if you think about it, set this equal to 0, and it moves it to x is equal to 3. Things that were not attached to the x, things that were added or subtracted at the very end, were our vertical shifts. Things that moved us up and down. This we moved in the direction that we would think. So if it was positive, we would move it up. If it was negative, we would move it down. So in this particular case, we're going to move down 1 space. So our horizontal asymptote is now going to be at y is equal to a negative 1, because we're shifting the entire rational function down 1. Our normal rational functions, our parent function of a rational equation. Parent function has the vertical asymptote at y is equal to 0 and x is equal to 0. These are our normal asymptotes for the parent function. And the graph would look like this. This is the parent function of 1 over x. Okay? This is the parent function. So if we go and shift that to our f of x is equal to 1 over x minus 3 minus a 1, we're going to shift this entire thing right 3 and down 1. So now what's going to happen is my vertical asymptote, instead of being at 0, will now be over here at 3, because I am shifting it right 3, and my horizontal asymptote will be at -1 because I shifted down 1. I have not flipped anything. Ooh, that's not good. And so my graph will be not a wavy one like that. Good grief. Will look something like this. It will still be on the top on the right, on the bottom on the left, but we have shifted right and down the appropriate number of spaces. So when you have a parent function and you're just looking at those transformations shifting in the denominator, that's going to shift you left and right. Sitting outside is going to shift you up and down, just like the transformations did. So think about those transformations that we've talked about before.